Last time we took the motor out. This time we work on putting one in. There's some improvements to be made to the engine before it goes in. We start by disconnecting the grounding and removing the fuel rail with the injectors. The O-rings on the injectors definitely can't be reused, so we'll need to be replacing those. Next, we disconnect everything from the throttle body and begin unbolting the intake manifold.
Should I be concerned?
I noticed some oil in the intake ports, but I decided it was best to pretend I never saw it. Now we remove the accessory belt and the alternator, which was damaged the last time we ran it. We're going to be running a new intake manifold, which should be buying us some clearance against the firewall, hopefully minimizing the contact made. We're also running an OEM alternator, hoping it'll solve our voltage problems. I also learned that if you're running a K20 water pump, run a K20 alternator. The K24 alternator leaves a gap like I'm showing here, but that's nothing a little grinding won't fix. Now, the intake manifold can be installed and torqued to 16 foot-pounds, and the throttle body can be attached and torqued to 16 foot-pounds. We can go ahead and replace the injector O-rings and then install the fuel rail. Place the insulating spacer and torque the hardware down to 16 foot-pounds. This intake manifold comes with some ports that we won't be using, so those will need a plug, and a barbed fitting will be installed for the one we are using. Back in the car, we can start by unbolting the vacuum lines in the engine bay and cutting the one that we need right before the bend. The other pieces can be scrapped. My camera focuses as well as I do, but here I'm just cutting the existing coolant line because we'll need to shorten it. Next, we unbolt the front motor mount in the engine bay and remove it. We remove the stock slave cylinder and install our new one for the swap. Minimize the fluid you lose here to avoid air bubbles as much as you can.
Ow!
After the fitting is threaded, reinstall the retaining clips. Next, we remove the stock passenger side and the driver's side motor mounts. This setup will use these, but I have another set that has the rubber in better condition. Keep in mind that the mount on the right side has a bolt that's accessed through the wheel well. With everything out of the engine bay, now's a good time to get rid of some of the dust and grime. Now we replace the motor mounts, but I'm only doing it hand tight, and we'll torque it down when the motor is in the car. Something I'm pretty sure I left out is the fact that I cut the shifter cable removing the stock motor, so this needs to be replaced. We start by removing the 4 bolts holding the center console in. I also need to unscrew my moldy gear knob. Remove the cotter pin and the washer, disconnect the shifter cable. I did this one-handed while filming, so the footage isn't great.
Oh shit.
Now we carefully remove the retaining clip and unbolt the bracket holding the cable. Now we just pull the cable out.
Nice.
To install the new cable, we need to remove the rear bracket and the grommet. With it removed, we pull the new cable through, install the grommet, and attach it to the shifter. One downside of replacing the cable this way is you won't be able to reinstall one of the supporting brackets. People claim doing it like this is fine, otherwise you'd have to drop the whole fuel tank. Back in the engine bay, we removed the fuse box and spliced some of the wires together. I went into greater detail in this in a previous video. Next, we have to remove the 10-year-old fuel that's still in the tank.
That's incredible.
We did this by using a drill battery to power the fuel pump and pump it into a waste bucket.
That just went on the floor, didn't it?
With the car ready, we go back to our engine and remove the engine stand mount. I noticed these weird little marks in the middle, which I assume may be Loctite that we applied. There's also one single hot spot on the flywheel, which I'm also going to ignore for now and let future me deal with it. I couldn't find my clutch alignment tool, so I stole the one from the Turbo Miata build that didn't quite fit, but at the time I thought it was good enough. We installed the pressure plate and torque it to 19 foot-pounds.
That's so heavy.
Putting the transmission on didn't feel right. The input shaft wouldn't line up with the clutch, so it turns out a proper alignment tool is important. I 3D printed myself a tool and tried again. We mount the transmission and torque the bolts to 47 foot-pounds. Next, we remove the Honda CR-V mount and install a new mount that our kit will be using. This mount is held on by 3 bolts torqued to 33 foot-pounds. With the transmission in place, we can mount the starter, held on by 2 bolts torqued to 47 foot-pounds. The starter also has the power and signal wires connected to it. Now we install the left motor mount to the transmission, again only hand tight for now to allow for adjustments.
Oops.
Next we install the rear mount on the transmission, torqued to 38 foot-pounds, and connect all the sensors to the wiring harness. On the opposite side, we route and install the accessory belt. Now we install the front motor mount. While installing, the holes on the one I got didn't align, so I had to drill it out to make it work. The mount is held on by 3 bolts torqued to 40 foot-pounds. There's just one more small thing to do before we install the motor. Now we can wheel the engine into the engine bay and slowly start lifting and aligning it. I kept the camera in place to show how much I lowered the car and raised the motor to get it to fit up. With both the side mounts attached, the front mount needed some convincing to align. Once aligned, we put a bolt through and torqued it to 47 foot-pounds. I tried my best to show it on camera, but next we need to connect a vacuum line from the port we installed on the manifold to the one in the engine bay we cut. Another benefit of this manifold is that the vacuum lines are on the bottom, giving us more clearance against the firewall. I installed the throttle cable. I had a little burr that wouldn't let the cable sit in the groove, so I had to go in with a Dremel and clean it up. Next, we install the clutch slave cylinder, held on by 2 bolts torqued to 16 foot-pounds. The best camera work I could do is to just show the location of it. Now, we attach our shifter cables to the linkage. Moving on to the wiring, the terminal with the white stripe goes into the fuse box. We feed the connectors through the firewall and attach it to our wiring harness adapter. Now, we replace our oil filter and fill up with some fresh oil. Next, we go through and torque the motor mounts to 38 foot-pounds. The bolt going through the left mount is torqued to 64 foot-pounds. I also bought a new exhaust header so it wouldn't contact the subframe anymore. The header is torqued to 33 foot-pounds. Next, we install our grounds to the chassis and then connect our battery. We used a piece of wood to keep the positive from shorting out to the chassis to prevent an accident like last time. I disconnected all the coil packs to see if it would crank and to let all the oil start flowing.
That's good. Sounds like it'll go.
Now that we know it cranks, we plug in the coil packs and see if it starts.
Cool.
That was extremely loud.
Very.
It's still pretty mind-blowing to me that it started that easily. Next time we'll continue to assemble the car and work on getting it running smooth. In the meantime, I'll be baking my neighbors a pie or something to make up for the chaos. Thanks for watching.